All right, thank you everybody for coming to today's presentation, Build Your Simulation Composite IQ. And today we have a special guest. My name is Dean Rose, and I work in product support for the simulation, or for the Autodesk Helius line of products, formerly known as the Autodesk Simulation Composite Analysis and Composite Design products. We got a lot of new information today that we're going to go through, and later on the product manager for this Helius product line is going to speak, and his name is Doug Kenik. So today we're going to cover what's new in Autodesk Helius PFA 2016. And to go over a little bit of what's been going on behind the scenes here in the last month or so. With the new composite products, there's been a name change. So when you look for these products in the Autodesk account, you'll notice a few little updates here. And if you're familiar with Autodesk Simulation Composite Analysis, that is now known as Autodesk Helius PFA. And you'll see it listed as such in the Autodesk account. And if you're a Simulation Composite Design user, you'll also see the Helius Composite 2016 listed in your Autodesk account. And those are a few of the name changes that we've added for this new release. And I briefly mentioned the Autodesk account. You may have noticed if you've logged in recently that the Autodesk Subscription Center has been retired, and that was as of March 13th of this year. And so now the format's changed a little bit. It's a little more user-friendly. Everything's organized a bit differently, but you should be able to find all the information you need in there more easily, and also be able to contact support. If you look up at the upper right-hand corner here in this image, you'll see a support link, and that's where you'll go to start initiating support requests or find your phone support information. And so we'll be referring to this as Autodesk accounts. You may not notice, or you may notice we stop referring to it as Autodesk Subscription Center. So the key word there for getting your online portal information, downloads, access to support, any services that you have available, those are all available on the Autodesk accounts. And if you get stuck, you can search our online knowledge database, and there's an article here that I've provided a URL for, and this will take you to everything you need to know about the account management in the new Autodesk account forums, or site. So I'll move on here. Another piece of information for everyone, we have a lot of new articles coming out on our knowledge site. The Autodesk Knowledge Network is what we refer to this as, and the URL is knowledge.autodesk.com. You can go there and search for all the products that Autodesk offers. Here are some of the knowledge articles that have been created recently for specific to the composite line. So you can click on these URLs once the PowerPoint is available. I'll make that available in the Box account, and you can go there and download that and access these if you're interested for more information. And I want to highlight a few of the ways users can get support. So if you have a question, the first place you can look at is our online help documentation. This has been updated for the 2016 releases. We have separate documentation for Helius PFA and for Helius Composite. And in there you'll find everything you need to know, from basic how to get started with the product, opening it, some of the basic features that you need to know when becoming a new user. And then we also have a lot of advanced information in there as far as theory and how we implement our solution to composites. So a lot of great information in there, and I suggest to everyone to try that area first. Next, you can go to the Autodesk Simulation Product Forums. A lot of great information gets posted in there, updates for the products, and users can also ask questions. And if you post a question there and you don't get an answer, it'll get escalated to the support team, and we'll reach out to you. But a lot of the time we have other Autodesk employees that provide solutions as well as other users, so it's a great area to go to and post your questions if you have anything. Next we have a question we commonly get on how to submit a case or how do we contact support. I've provided a link here for submitting and viewing support cases, so it walks through the process on the new Autodesk account site and shows you how to submit a new support case or how to view your old support cases that you've entered and keep a status, an active status of that. So another great place to look. And then lastly, if you're looking for phone support, you can also go to the Autodesk account, and this link here will show you how to find your phone support information. Things you'll need to call in are your customer service number or your Spec ID, and also the number. And then along with that, you'll be able to find your serial number and things like that. So hopefully, if you need information like that, it's all available. And lastly, this presentation, once the webinar is done, we will post the PDF version of this document along with information that Doug is presenting, and we'll make that available to everyone for download. And then you can also have a link to the webinar in case you need to review some information. That'll be available on YouTube. So, all right, and without further ado, I'm going to pass this off to Doug Kenik, the product manager for the Helius product line, and he's going to speak a little bit about what's new in the 2016 Helius PFA release.
Thanks, Dean. Let me start sharing my screen here. All right. We good, Dean?
Yeah, go ahead, Doug.
Cool. All right. Well, thanks, Dean, for the introduction. I guess I don't have to go through those 5 seconds. So today we're going to be talking about what's new in Helius PFA. So we have 2 Helius products. One is called Helius Composite. The other is called Helius PFA. And I want to focus our time today on Helius PFA. If you have questions about what's new in Helius Composite, I urge you to go over to SimHub, so it's www.simhub.autodesk.com, and there's a whole slew of videos on SimHub talking about what's new, including what I'll be presenting today and individualized videos for each of the new features. Some semantics before we get going. As Dean mentioned, Autodesk Simulation Composite Analysis is now called Helius PFA. So the names have been rebranded for this year. They're the same exact product, just with a different name. We've moved back to our firehole naming before we were required by Autodesk. So Helius used to be the name of this specific product, and now we get to take that back. It carries a lot of weight in the nonlinear progressive failure analysis world, which is what PFA stands for, is progressive failure analysis, which is the bread and butter of this product. So for those of you that don't know, Helius PFA supports both what we call continuous fiber composites, which are typically referred to as UD or unidirectional and woven, like plane weaves or 5-harness satins and stuff like that. We support progressive failure analysis and fatigue analysis for those materials. But we also support chopped fiber materials and non-filled materials, and that's really what I want to focus our attention on today, is what we've added to support chopped fiber materials and non-filled materials within this code. So here's what's new in Autodesk Helius PFA 2016. I'll hit each of these individually. For those of you who attended the last webinar where I discussed what was new in 2015.1, some of this will be a little bit of a review, but I wanted to make sure that we hit on all of it again, just because it is related to this new release in 2016 so much. We were able to turn around this product in a matter of 4 to 6 months and re-release some technology, which I think is pretty powerful. And if you have any questions, just feel free to type them into the question box. If I see them, I'll just stop and answer them. Otherwise, I'll answer them afterwards. Very informal presentation. All right, let's talk about advanced material exchange. So I group Helius PFA into two different groups as far as what its capabilities or what it's shipped with. The first is what I call advanced material exchange, which is a desktop utility. And this desktop utility allows you to map data from mold flow over to the structural simulation. And the second portion that I'll talk about after this is the solver. And the solver takes that data that's been to the structural simulation, and it'll use it in a finite element analysis with Abacus or ANSYS. So let's touch on advanced material exchange. So as I mentioned, advanced material exchange maps data from mold flow to structural simulation. And we typically see there's two different groups that are running these simulations. One is performing the manufacturing simulation, which is the mold flow simulation. The other is performing the structural simulation in Abacus or ANSYS or Nastran or what have you. But there's usually a disconnect between those two groups. On the structural side, we usually are using isotropic assumed material properties, and we're not taking into account any fiber orientations or any residual strains contributing to warp. So it's kind of either a gross over or underestimation of the material response. We really don't know. We're just kind of iterating down in that space without any information from the mold flow simulation, which is really important because the fiber orientations and even the residual strains contributing to warp can impact structural simulation significantly. So we created Advanced Material Exchange, bundled it with Autodesk Helius PFA to map the data from mold flow to the structural simulation. Specifically, we support now Abacus and ANSYS. So in 2015.1, we released with only Abacus support, but now we also support ANSYS workflows. We can read in ANSYS.inp, .cdb, and .dat files that are created either from Workbench or ACP, and we can perform the exact same workflow as we have before. So we will map all the material properties that are available from mold flow, as well as all the fiber orientations and even residual strains which contribute to warp. The cool thing is, in this release, we also allow you to visualize what those residual strains are from the warp simulation. So you can actually determine, specifically for non-filled materials, if your mapping was successful. Since non-filled doesn't have a fiber orientation, you want something else to look at, so we'll show you the residual strains from warpage. As I mentioned, we support fiber-filled plastics. That's what Advanced Material Exchange was originally created for, but we also expanded the support for non-filled plastics. For those of you who don't know, there is a product called Autodesk Mold Flow Structural Alliance, or AMSA, which is no longer supported due to the fact that we created Advanced Material Exchange. One sec, I got a dog drinking some water in here. Due to the fact that we created Advanced Material Exchange, we stopped supporting Autodesk Mold Flow Structural Alliance so that we could pick up the capabilities in Advanced Material Exchange, support it on the technical side, which is obviously what Dean helps us do, and continue to update it as we release new technology. So we've added support for non-filled plastics so we can map residual strains over for those. And we've also added new material behavior. So originally we had elastic plastic material behavior, and we added something for for linear elastic material behavior as well. And this is really powerful because the most common thing that we see when we introduce Advanced Material Exchange to customers is they don't have the required nonlinear material data to run an elastic plastic analysis. But mold flow has all of the linear elastic material properties for that specific material. So now we can help users get started with Advanced Material Exchange by approximating material behavior as linear elastic, taking into account the fiber orientations, and allowing you to run with those simulations while we get you up and going with nonlinear elastic plastic material behavior. All right, so let's talk about supported mappings. So we can map a single part for an assembly, and I think that's pretty important and something that a lot of people get confused about is we can actually bring in an assembly to Advanced Material Exchange, but we can only map data for one of those parts. So a lot of the times what we'll see is an assembly made of steel and plastic parts. Maybe just one of them is plastic. So we can map that data for the plastic part and keep the steel as it is, like we're doing here. We can map solid to solid, so that's a solid mold flow simulation, to any 3D element, or sorry, to some 3D elements in the structural simulation of Abaqus and ANSYS. And we can also map midplane to shell. So we can map midplane mold flow simulation to a shell simulation in a structural. And here I'm showing that we can actually go from the bottom to the middle to the top and show you how those fiber orientations or even residual strains change through the thickness of your shell model. So here's the list of supported elements that we have for the 2016 release. The reason that we have specific elements that we support is on the front end, or the advanced material exchange side. We actually use the element shape functions to map data from Gauss point to Gauss point, or sometimes people call those integration point to integration point on mold flow and structural, to provide you, the user, as with the most accuracy. So we singled out a few different element types that we really want to support, which are 4-node TETs, 10-node TETs, 8-node hexahedrals, both fully and reduced integration, and 3-node shells, and finally 4-node shells, again, both fully and reduced integration. So we carry pretty much capability for all element types. The one thing we don't support right now are 20-node bricks and wedges, which are 6-node elements, with those coming in the near future. Okay, so let's talk about software compatibility requirements and other requirements for running advanced material exchange simulations. Again, we're just on the front end, so we're talking about mapping the data over and setting up your simulation to run in structural. So what we do require is Mold Flow Insight. 2015, 2016, Advanced Material Exchange is built on the Synergy platform that Autodesk Mold Flow is built on, so it's really great for us because we pick up any updates that Mold Flow does along the way as well. We'll support Abaqus 6.12 to 6.14 and ANSYS 14 to 15. So that includes 14.0, 14.5, and 15. Again, you can run this in Workbench or you can run it in ACP. I know ANSYS 16 was released a few months ago, and we're working on supporting that with an update here in the near future as well. So let's talk about what our material data requirements are if you want to run a simulation. So for fiber-filled materials, if you want to run a linear simulation in your structural analysis, all you need is the MoldFlow UDB file or the MoldFlow DB file. And we'll take all that data over automatically in Advanced Material Exchange, so you don't have to approximate. All you need to do is hand or acquire the MoldFlow study files, and you can suck those into AME and we'll automatically transfer that data over. If you want to run a nonlinear simulation, though, we do require that you enter some nonlinear stress-strain curves to failure. One, what we call aligned with the flow, so we can assume this is some sort of a plaque, and we have the flow coming into the plaque and dispersing. So we ask that you give us a stress-strain curve to failure with a tensile bar cut in the direction of the flow, one cut perpendicular to flow, and then finally one cut at 45 degrees to flow. And the 45-degree data isn't required, but it definitely is helpful for calibrating our response. The cool thing about the 2016 release of both MoldFlow and Advanced Material Exchange is that now you can also enter these curves in MoldFlow, and that data will be transferred automatically into AME when we read in the study file. So that's really powerful. Now you can have a single source of the data that's ran with both the MoldFlow and the structural simulation. So let's talk about non-filled materials. Again, if you want to run a linear simulation, we'll automatically suck in the mechanical data from MoldFlow. No other entry required from the user. But if you want to run a nonlinear material simulation, again, elastic plastic to failure, we need one nonlinear stress-strain curve to failure. So let's just say it's aligned with the flow. Now, I know that there are non-filled materials that exhibit orthotropic material behavior, and MoldFlow does handle those types of materials, but we're disregarding those types of materials for now in Advanced Material Exchange. We're assuming isotropic material behavior with potential for expanding that in the future. And I think I had a question come up last time I gave this presentation on if we map over CTEs. We definitely do map over CTEs from mold flow, and those are included in structural simulations as well. All right, so that was advanced material exchange. Again, that maps data from mold flow to a structural input file like Abacus or ANSYS. Now what I want to talk about is the capability we've added to our solver. And the solver can take the data that's been mapped from advanced material exchange and use it with the solver. So AME creates an auxiliary file, so it'll create your new input file for your structural simulation, and it'll create another file that's called a SIF, or a .sif, which is called structural interface file. And the structural interface file can be read by our solver, and our solver will then use that data and apply it to the structural analysis in conjunction with Abacus or ANSYS. So it runs on the back end. You really don't even know it's there, and we're constantly updating the structural analysis using the data in the structural interface file. So I see a question from Eric. AMSA was supplied free with Mold Flow Advisor Ultimate, so it will now disappear. And Dean, did you answer that? No. So Eric, I don't know if it'll disappear. I think that we just won't update it. So you won't see it being updated for the new versions of Mold Flow or the new versions of Abacus or ANSYS. I will tell you we're looking into supporting Mold Flow Advisor Ultimate. We don't yet, I know that for a fact, but definitely something that we're interested in because I do want to replicate the behavior of Autodesk Mold Flow Structural Alliance. And Rajitha, I hope that you can see my screen now. I hope that it's not black anymore. I'm sorry if it still is. All right. So let's talk about solver technology with fiber-filled and non-filled plastics. Awesome. So again, coupled with advanced material exchange. So our solver technology contains both continuous fiber composites and chopped fiber composites. And I'm going to focus on chopped for now because I think it's the most interesting. It's the portion of the solver that accounts data, takes into account data that's been mapped from advanced material exchange to your structural simulation. So again, the solver can read that structural interface file and use the fiber orientations in your simulation, which are really important, which is really, really important. Fiber orientations basically dictate the orthotropic material behavior of fiber-filled materials. If you're not accounting for fiber or orthotropy, you can really get yourself into trouble on the structural simulation side because they drive, that material response drives plastic material behavior, stiffness, as well as rupture because as you can imagine and as you can see on the screen, you can get locations of weld lines, which we're seeing right there, and that's basically where the fiber orientations meet and then go perpendicular or parallel to each other and flow, and that can cause a large amount of stress concentration, which can drive plasticity and failure. So we really need to be able to take those into account in a structural simulation. And again, we can use residual strains contributing to warp in the simulation, and this is powerful for press fitting. A lot of users want to understand what happens when you have a warp shape that comes out of mold flow and then you go ahead and press fit it into a location, or maybe you bolt it into a location and you want to understand the deformation or the deflection of that part once you put it into place, if it's going to be suitable enough. So we can use that as well. Again, we can run a linear material, so we can take those properties over from mold flow and apply them to the structural analysis. You're obviously going to be missing out on any plasticity and rupture at this point, but it can help you understand the stiffness in the elastic regime of your material. And finally, nonlinear material responses. We can handle elastic plastic, and it's directionally dependent, and we can handle failure predictions or rupture of the matrix constituent of those fiber-filled materials. Cool. So here's something else that we've added that is really cool. This is called element deletion, and this is applicable to both continuous fiber and chopped fiber microstructures. And what you're seeing on your screen is a video playing and we're removing elements. So Abacus 614 added functionality to remove elements in an implicit analysis. And usually you can delete elements in an explicit or dynamic analysis, but this is kind of one of the first times we've been able to remove elements in implicit, and it's really powerful because once you get material failure and you lose stiffness of that element, you want to get the element out of the analysis because it can wreak all sorts of havoc on convergence. So now you can turn on the option to remove elements after failure. So that's what's being shown on the left-hand side of the screen. This is a continuous fiber composite, and there's a crack growing from the notch tip all the way through the plate, and we're removing the elements as that crack grows. We're basically simulating crack growth at this point, which you cannot do as efficiently if you do not remove those elements. And then on the right-hand side of the screen, we're showing a cruciform specimen with a chopped fiber material. We're pulling on it, and you can see it just kind of breaks in two, and we have some material coming flying back at us out of the screen. So again, that's only supported in Abacus 614.1, extremely powerful for progressive failure analysis of both continuous and chopped fiber materials. And we've also added what we call an API for damage initiation, and this is only for continuous fiber composites. So this is for woven and unidirectional, which are shown on the screen from top to bottom. And now we can allow users to define their own failure criteria. So we come prepackaged with a host of different failure criteria for continuous fiber composites. Sometimes users have developed their own in-house, and we want to make sure that we can allow users to couple that with Helius PFA technology. And by that I mean we give you access to certain information that most codes do not, such as what we call constituent information. So if you write your own failure criteria now, you can write a failure criteria at the fiber and matrix level, which would be fibers are the blue, matrix is the orange, and that same microstructure is present in each of these toes here. So you can write your own failure criteria at that level, and we'll give you access to the fiber and matrix stress and the material properties. So we'll decompose what we call it from lamina level to fiber and matrix level, and you can write a failure criteria at that level. We'll also give you access to the MCT failure criteria, which is the most powerful failure criteria that we have in Helius PFA. And finally, we'll give you access to what we call microstructure information, which basically means fiber volume fractions, which is a measure of how tightly these fibers are packed together. We'll give you access to fiber and matrix material properties. We'll give you access to if it is a continuous fiber composite, a woven composite, and if it's woven, we'll give you access to is it a 4, a 5, or an 8 harness satin. So Eric threw out a question again, any plans for AME interfacing with other FEA packages such as ADSK, SimMech, and Dyna? Eric, I will say that we're in development right now looking at what we can do with ADSK Nastran. That'll be a really interesting little tidbit that we can add in the future, and Dyna is obviously on our roadmap as well. To be able to go into Dyna, we need to have a rate-dependent material model, and we need to start considering something that happens in compression, because a lot of the time those materials or those structures are put into compression, and they have different rates around the structure. So that is also a research topic that we've started internally, and we're going to see where we get with that. Boom. You got it, Eric. Okay, so that is damage initiation. So that's great for understanding where your structure fails, but a lot of the times you want to understand how it fails. So once you get a damage initiation, you want to understand how that damage keeps evolving. So we've also added a functionality or an API for damage propagation, and this is only for unidirectional continuous fiber composites, but still very powerful. And damage propagation, what I mean is after the matrix fails or after the fiber fails, what happens in this microstructure? Is there a crack in the matrix? Does the fibers break, or do the fibers break? And if so, how does that affect the response of this overall composite material? And that's how progressive failure is really controlled, is by dictating the response of the material after failure. So now users can define their own damage evolution. after something has failed, and it's what we call IDSM controlled. So IDSM is a nickname for Intelligent Discrete Softening Method. And one of the coolest things about Helius PFA is that it has convergence technology built in. And by convergence, what I really mean is when you start doing progressive failure analysis in implicit FEA codes such as Abacus or ANSYS, and you get a failure, a lot of the times the FEA code has a really hard time understanding how to converge on the solution after that happens. And it'll sit there and churn and iterate and try to understand how to redistribute the stresses and strains around the structure so that it can resolve equilibrium, and it takes forever. So we created what we call IDSM, which helps the finite element solver understand how to redistribute the load after failure and push through those nonlinear events. So we have way more efficient solutions coming out of implicit FEA analysis now. That's a great new feature that's added in this API. Again, we give the users access to constituent information like the fiber volume fractions, the material properties of the fiber and the matrix, what type of microstructure it is. And finally, we also offer them access to what we call our micromechanics routines. What that means is if I degrade the properties of the fiber or matrix, I need to be able to predict what happens at the composite or lamina level. And we give you access to a routine that will take those two material properties and spit out what the properties of the composite are. So that's a great little addition as well. All right, so done talking about API. Again, I think in 2015.1 we talked about this, but we've added expanded language support. So now we support German and Japanese in 2015.1 and 2016, with more to come in the future. And that's all I have for this presentation of Autodesk Helius PFA. Again, I encourage you to go to our product centers on Autodesk.com and learn about the new features. There's What's New videos tagged on the feature site, and the Sim Hub also has our What's New presentation along with a lot of those same new features listed in the videos. Dean and I are constantly posting blog posts on the Sim Hub blog talking about new features, new functionality, release dates, kind of what we're thinking for timelines on some of this new functionality. And it's really where we keep in contact with our customers, as well as the forums, as what Dean mentioned. We're on those all the time answering questions. So feel free to reach out to myself or Dean with any questions, and we'll answer them as we go along. Thanks, everyone. Any other questions?
Thanks, Doug. I don't see any other questions right now. We'll give everybody a few minutes to wrap their heads around this and throw out any questions if they have them. And I just posted a link there to the SimHub Autodesk.com blog. You can go there and check out what we have up there.
All right.
Okay, looks like it's pretty quiet here, so we'll go ahead and wrap this up. I want to thank Doug for coming on and talking about the product. So a lot of great information.
Thanks, everyone. I'll talk to you soon.